Good afternoon, everyone. Thank you for attending today's webinar on commercial air barriers. This was a change in topic because the 2024 IATC was a bit more delayed than we anticipated, but we will be presenting on that in the future, so definitely keep an eye out for it. The webinar today is going to be recorded. The recording's posted to the Code Adoption Toolkit within a week or so. So keep an eye out for that as well. If there are any issues with audio, feel free to write me in the chat. My name is Erica Dello, and I'm a project manager for NORESCO. This series is sponsored by the Colorado Energy Office with training materials created by Shomskoda Associates. So Hope and I have been working with the Colorado Energy Office to provide trainings just like this one. This one is the second to last in this series that we've got scheduled. We've got one more session before we all leave for vacation on July 3rd, and that's just bring questions, code questions. You know, it's more of a discussion type of session, so we're here to answer any code questions that you have. We also have what's called role-based trainings, and those role-based trainings are essentially focused on the code user's point of view when trying to comply with the energy code or trying to enforce the energy code. So if you're an architect, an engineer, a builder, a rater, building department inspector, or plans examiner, permit technician, we've got training specifically for you on the IACC. So definitely reach out to me if you guys are interested in setting up a training. We also offer technical assistance for code adoption. So if you're looking to update to the latest codes, we're here to help. We've got, we can support you guys in a whole bunch of different ways, whether it's presenting to city council, engaging with stakeholders, answering questions, drafting amendments. We're here to help. All right. And then, of course, there's the Energy Code Adoption Toolkit for those of you that are new to these sessions. This is a toolkit that has a plethora of resources on it, but the one that I want to highlight today is the Colorado Codes Helpline. Definitely use it. You can submit a question on any of the building codes, and a subject matter expert like Hope will get back to you in just a couple of days' time. So it's a really great resource if you've got a question on how to comply with something, or how to inspect, or how to review. We're here to help. Okay, so I think that's the end of my slides, but just a couple of housekeeping items before I pass it over. If you have questions, feel free to use that Q&A function, and we'll get those over to Hope at the end of today's session. And I think that's pretty much it, but Hope, so I'll go ahead and pass it over to you.
All right, and I will do my best to get this to share. All right, how are we doing? Are we sharing a screen? Wonderful. All right, well, welcome everyone. We're gonna have some fun diving into the commercial air barrier section of the code. It is a little bit different than we may have been used to in the past, and there are a few questions sometimes about how to implement a lot of the requirements that you'll find. So we're gonna take a look at it. Now, the reason why there is such a huge emphasis on air barriers is because the air barriers are part of that thermal envelope assembly, right? We know an assembly is a bunch of components working together, really trying to do a specific, we'll call it a job, as far as what that component is working on. Now, when we talk about the thermal envelope, a lot of times people think about insulation, and insulation is absolutely one of the items that are a part of that assembly, but the insulation really cannot work on its own. It's got to have that air barrier component with it to make it all function together. So insulation. The big thing about insulation is it's there as the thermal resistance, right? Keeping the heat from either leaving the structure or keeping the heat from entering the structure. And it gets that thermal resistance, and we measure that with the R value. for the actual insulation itself. Now, the R value is actually created by all these little stagnant pockets of air. And those stagnant pockets of air are really what makes that insulation material work in that thermal resistance. If you do not have an air barrier that's going to control and hopefully stop the movement of air going through there, what ends up happening is it strips away all those stagnant pockets of air. So you have a material in an assembly that's you spent money on that is actually not working at all. So the idea is wherever you see insulation, when it's part of the thermal envelope, then you should always have an air barrier with it to make sure that the system works together. The AIA credits, I think that's something that Erica would be able to address on that. Okay, so the code is all about trying to provide tools and assistance in being able to navigate and get the best product out into the field, right? So if you see the image on the left-hand side, C103.2 is a list of items that must be placed on the construction documents. Now, the items on the left-hand side are what you would find in the 2018 edition or older editions. The reason I have the two on the screen is because the one on the right-hand side is the list that you're going to find within the 2021. And the importance of this is you'll notice number 12 became number 13 because we added the energy compliance path that has to be listed on the plans. But 13 changed from air sealing details to specifically call out air barriers and air sealing details, including the location of the air barrier. And part of that is because while in the earlier editions where it was called air sealing details, people often didn't understand that that required those air barriers, not just some air sealing, because the section that this is referring to used to be called air sealing, right? So you had to demonstrate how tight your building was through a calculation and all that. And then in the 2012, they created kind of like this prescriptive option, for a lack of a better word, that just kind of walked you through, hey, do X, Y, Z, and we'll be able to have, you know, a really good system going. But there was a lot of confusion because it said air sealing to it. And now in the 21, it really lists out what everything that would entail with air sealing and air barriers. Okay. Now, this class is focusing on the 21, but there are some things because of the changes to really address where those differences come in, because it may not look like they are different from what you would find in earlier editions. So in the previous edition, you really had two options in how you were going to comply with the air leakage requirements. You could either do what would kind of be that prescriptive approach where you're going to comply with C402.5.1 all the way through C402.5.8, or you could go ahead and do the testing approach, which would kind of be considered performance, and demonstrate that you didn't exceed the air leakage rate of 0.4 CFM per square foot. You still had a few sections that would be kind of considered, quote unquote, the mandatory. You would still have to comply with those, even if you did do the testing approach. Now, what I will say is the majority of the time, or I should really say, I don't know of an instance where I had a project that actually utilized the testing option. It was always, we're going, you know, with the prescriptive option of it. Now in the 21, C402.5 is still very, very similar, right? It still says you're quote unquote prescriptive. You're going to comply with C402.5.1. This time you're going to go all the way to C402.5.11.1, or you're going to comply with the testing approach where you meet, you know, the CFM parameters. You're going to, you know, follow through some of the other things. Plus, you're going to do these sections that are the same sections that we saw in previous editions that were required. But the reality of what this is showing you is really not the case, because it's not as cut and dry as it was in the past. It's kind of all intermixing, and hopefully we'll be able to kind of untie the knot that has been created in this section. So the first thing is, you know, you are still required to comply with the air barrier sections, and you also have to make sure that you're complying with C402.5.1 and C402.5.1.2, unless you happen to be in climate zone 2B, which none of us here in Colorado are 2B. So you're going to have that continuous air barrier, and you can have that air barrier located on the inside or the outside. I've seen combinations of the two that, you know, are out there, but it's really important to understand that when you are going prescriptive, where you're going the C402.5.1, which is this, all the way down to C402.5.11.1, this section is saying, hey, don't forget C402.5.1.1 and C402.5.1.2. Now, we're going to jump ahead, skip the 0.1, and we're going to take a look at the 0.2, because I think it's incredibly important for us to see where things are going. So C402.5.1.2 has 3 items in there, and what it says is you are going to comply with the following, and it's saying all of it. So the first one says, hey, any building that happens to contain, or portions of a building that happens to contain, a group R or group I occupancy, you are going to have to follow the provisions that you find in C402.5.2, right? So we'll take a look at that. Now, there are some exceptions, but the exceptions that you see here do not pertain to any climate zone here in Colorado. So if we look and see what C402.5.2 is telling us, we're looking at this, and basically what it demonstrates is that we have testing requirements now for those R2s, or those R occupancies and those I occupancies. Now, when you look at everything that's here on the screen, you'll notice all the lettering is in blue. That means it's new language. It's a whole new section. But this looks very complicated. And while there are some nuances to it, I think it's a lot easier to show what the whole language is. But let's skip to what our Cliff Note version of what they're trying to say with this. So basically, what we just looked at is telling us that we are going to test our dwelling and sleeping units. Now, the testing needs to demonstrate that these units do not exceed 0.3 CFM per 0.3 CFM per square footage when we are at 50 pascals. Now, it does allow for you to do an area weighted average of those units that you're doing, but it also says that you have to perform an unguarded test, and we'll talk about that in just a moment. It also takes into account that not all buildings or structures that have dwelling and sleeping units are going to have 400 units within it. You sometimes have smaller units, and sometimes you do have those 400 units. So are you going to require 400 units to test and cost that much more, or is there something that we can do? And so this is how it was put together. If you have 7 or less units, dwelling units, sleeping units within a building, you are going to test all of the units. Now, if you happen to have 8 or more units, Now you have where kind of that flexibility kicks in for it. And you only have to test 7 of those units or 20% of the units. And it's whichever number is larger, right? So if you have 100 units, 20% is 20. Obviously, 20 is more than 7. So you're going to test the 7. Now, the other thing that it does require, because you have multiple options as far as what and where you're going to test, there are very specific parameters of units that they want tested. So out of the 7, we'll say you have to have 7. Out of those 7, one of them has to be a unit that's on the top floor. One of them has to be a unit that's on the bottom floor. And then you also have to have a test for whichever unit has your largest square footage for it. And then the remaining 4 can be an intermediate mix of, whatever unit you would like to put on test. Now, there is a little bit of a kind of like a prescriptive, what do I do if it doesn't pass type of situation. So what it says is for every 1 unit that fails, you will then have to test 2 more units. So obviously the incentive is I only want to test 7 units. I don't want to keep going and testing. And then I'm doing 100% and my entire building does not pass. That becomes an issue. Now, I mentioned earlier that you are required to do these as unguarded tests. So by raise of hand, how many of you know what an unguarded test is? Raise your hand. Well, I would hope so, Brad. If you didn't know what that is, we were going to have a discussion. All right.
Question for you.
Yes.
Who chooses which units get tested?
That's a decision that would be made between the builder or contractor and whoever is performing the test. So, I mean, outside of doing one on the top floor, the bottom floor, and the largest square footage, even within those, the contractor, builder, rater, they're the ones that are going to determine that. The code officials don't say, hey, I want to see this unit done. The decision is with really who is building. Great question. All right. So it looked like quite a few of you are not very familiar with what an unguarded test is. So you are in luck. I am going to break that down for you. So typically, an unguarded test is where you have one dwelling unit that's on test at a time. If it was a guarded unit or a guarded, let's see if I can do this. If it was a guarded test, and we were doing that middle unit, you would do this one, this one, this one, and this one. You would put all of these on test too. And what you get is you have all of these pressurized, and it skews the results slightly. So in the code this go around, what they're saying is, okay, you know what? You cannot do a guarded test where everything is on. You have to do that individual unit. So now we know whether that individual unit is actually, a tight unit, and that we're able to really be able to control what our, let's see if I can make this work. What our intentions are, right? Okay. So that was number 1. That was if you were a group R or group I occupancy and what your requirements are. Now, if we go and look at number 2 tells us any building or portion of a building that is not a group R or a group I occupancy is going to have to comply with C402.5.3, which we'll look at But first, we really need to take a look at the exceptions. Now, exception number 1 is not going to be pertinent for anybody here in Colorado, but exception 2 does have some possibilities. So if you have a building that's larger than 5,000 square feet of floor area and you're in climate zone 4B, you would be exempt from this requirement that we're going to talk about. Now, the other exception that does come into play is if you're a building that's between 5,000 square feet and 50,000 square feet and you're in climate zone 5B, you're exempt. So 4,999 or 50,001 will still have to comply with it, obviously. So let's go ahead and take a look and see what all the fun and excitement is for C402.5.3. So here is the actual verbiage of what you're going to find when you look in the code itself. Again, I think this is a whole lot to kind of take in. And I think it's important to know what the code says and how it looks, but let's clip note this sucker and see if we can make it a little bit easier to understand. So really what they're talking about is there are very specific standards that will need to be utilized when you are doing your testing, right? Typical, we know that. The other thing is you cannot exceed 0.4 CFM per square foot when you're at 75 pascals when it's under test. Now you do get to take an area weighted average of those spaces and determine about the 0.4 CFM per square foot. Now, just like with the other section, there are very specific locations that are required to be placed under test. So the first one is if wherever story you have that is under a roof, that entire story is going to be required to be placed under is required to be placed under test. So I'm going to show you something. So keep in mind that, let's say here's a building. And just remember that I am creative and not artistic with my drawing. It's actually turning out pretty well here. So let's say this is our building and the spaces that are under the roof, which is here. And then this now becomes where the roof line is, right? For this area. So both of these would be required to be placed under test under just the first one. All stories under test or under roof will be required to go under test. Now, the next one is any floor or story that happens to have a building entrance or has exposed floor, has loading docks, or is a basement will be required to be on test. So if by chance you had on this side that this is where your grade is and a building entrance is here, then this would be the floor there. But if you had a building entrance here and the grade is down here and you have a building entrance down here, you now have two floors that may be required to be on test just because you have building entrances there. Does that make sense for everyone? Did I raise your hand if you have any questions about what I just said, because I know it gets a little confusing. And then for the remainder of the area that's available, you are required at that point to go ahead and put 25% of that on tests. Now, the good news is, because, you know, when we talk about air testing, air barriers, and this whole concept, residentially, we've been doing it for a very long time. We've had the opportunity to practice, right? We've had times we failed. We've had times that we succeed. In the beginning, there were probably more failures than there were succeeding, which is okay because you learn great things when you fail. The energy codes here is now saying, hey, we get it. we know that there's going to be situations where you fail. So what do we need to do? So now what they say is if you exceed the 0.4 CFM, but you're less than 0.6 CFM. So they're giving you a little bit of leeway saying, okay, we know that there's a little bit of problem, but not like a Big Mac truck is going through the building type deal. Then what we're going to do is say, put it under pressure, utilize infrared gun or a smoke test and go around the building and find where that leakage is happening. And then go ahead and fix that leakage. And what that does is you are considered to then be good. You don't have to retest everything on that, but you will be required, if this happens, you will be required to provide a report to the building owner and to the code official that says, hey, we found out that this was our issue and this is how we fixed that issue. Now I'll tell you, there was a jurisdiction who's already had the fun of having to test. They had a project test and it was more than 0.4, less than 0.6. So they did the fun of the prescriptive trying to figure out where it was. All it was, their only leakage was there was a plumber that had put a pipe through where the electrician had utilized this really nice flashing system and thought, oh yeah, well, I'll just put it right through there. Well, when he did that, he destroyed that flashing system and it did cause, some issues, and that's where they failed. So not picking on plumbers, that just is what happened in this particular situation. So let's see if I can get that to work. There we go. Now, the third option here, or the third number in here that would need to comply with says, hey, if you don't fall under number 1 or number 2, because you meet the exceptions or whatever the case may be, because number 1 says group R and I occupancies, and group 2 or number 2 says anything other than group R or I occupancies, but it does have some exceptions to it. If you fall in one of those exceptions, you are now doing what number 3 is. Now, number 3 says you got to comply with C402.1.3, which is our materials section, and 0.4, which is our assemblies section. And then it says, hey, guess what else you get to comply with? You get to comply with C402.5.1.5. So what does that mean? We have this lovely section now that says building performance verification. Basically, what you're going to do is you're going to do thermal envelope commissioning is really how it comes down to. So there's going to need to be verification about that the air barrier is continuous. Now, there are some options about who can do this. The code official can say, hey, we're doing this. This is going to be ours that we're taking care of. Or they can allow that it can be a registered design professional. It just can't be somebody who's associated with the project or an approved agency. So those are the groups that are permitted to do the continuous air barrier verification. So whoever is going to perform this is going to review the air barriers that are found on the plans. They're also going to go out and do air barrier inspections out in the field. And then when everything is said and done, they are going to write up a commissioning report. And in that report, it's going to say what deficiencies or issues that they found on the plans and then how they were corrected. They will also then include and document the issues and deficiencies that they found out in the field and how it was corrected. And then this report is going to be provided to the building owner and to the code official. Any questions concerning the big emphasis on the new sections and the new testing requirements? I know that's kind of a lot, and I try to break it down to make it a little bit more digestible. So if you think of something, throw it in the chat, raise your hand, whatever the case may be, and I'll try to keep a eye out on all
Hope
the.
there is one in the Q&A.
Oh, okay.
Would the test be prior to drywall installation, or can the drywall be used for part of the assembly?
That is an excellent question. I'm gonna partially answer it now, and then you'll probably catch it later. Typically, it's going to be done towards the end of construction. Is really what it's going to be, because drywall can be part of the air barrier strategy that can be utilized for a building. So typically, they're going to want that drywall to be installed before they go and do the testing on it. So great question. I like that question. All right. Well, I'm having, and I appreciate it, Erica, because I'm having a hard time seeing any of the Q&A coming up. So
Yeah, no problem. I'll let you know.
thank you. All right, so air barriers. So now we're going to start hitting the sections that we're probably very familiar with. But I think after seeing what we just talked about, now these sections probably are a little bit more weighted in making sure that we get it what we really need. Because remember, we do need that continuous air barrier. It needs to be continuous all the way around. A lot of times there's attention that's paid to it when we start looking at and thinking about the walls, right? But guess what? Those roof and below grade walls potentially could need to have that air barrier component with it also. So just remember, it goes beyond just those exterior walls. So this section is telling us, hey, you've got to comply with all of the following, and there'll be a list here, another list. Lists are good. I know people don't think lists are good. I love lists. I think it's much better this way than having it all in one paragraph getting lost. So this tells us that you've got to have a continuous air barrier all throughout the thermal envelope, and you got to pay attention because it's got to go across joints of assemblies. So we know that there's going to be, we all know that there's different joints of assembly because there's different materials that are utilized. There's different designs, and we have to take that into account when we are thinking about this. The other thing we have to think about is we have all these various types of materials, and I have yet to see a material that is tall enough for a 50-story building that it's just one length of a material, right? It's usually multiple lengths or items stacked upon each other and all of that fun stuff. But the reality is, what doesn't get paid attention to a lot is thinking about sealing up those joints and seams. So we need to make sure we seal up all the joints and seams of the air barrier construction, whatever that material assembly is. All of those joints and seams need to be secured, and it's not just using like tape, right? You might be able to use tape, but the thing that you have to think about is whatever you utilize has to be able to maintain the integrity of that air barrier when it's dealing with, positive and negative pressure from the wind, stack effect, mechanical vibration. I know we've all seen those line sets that vibrate enough that everything is basically gone where it enters the building. I mean, those are things that we have to pay attention to and think about in our design when we're looking at it. Now, here's a fun one for you, penetrations. I had a opportunity. Let me see if I can find that picture really quick. But penetrations have to be paid attention to. You have to seal those up. And a lot of times that is one that gets missed. And it's a perfect opportunity of where you're going to have air infiltration going into that assembly. And just like I said, I told you the story about the project that ended up failing. And the reason it failed was, because a penetration hadn't been sealed, or they hadn't utilized the correct type of material. But I'll tell you, if you don't specify and have this information on the plans and take a look at it and think about it. I was at a Starbucks, And let's see if it's, oh, I don't have it. I was at a Starbucks and I jumped out of the car because I saw this. Here's a penetration that's going through that thermal envelope there. They didn't have a whole lot of information as far as what they were going to do. Obviously, they thought about the fact that they had to seal that up. But if you looked, you could look through the wall. I could look and see the drywall on the other side of the wall. If I can see it, you know how much air is moving through these penetrations. Plus, if you look at it, I think they kind of way overdid the sizing of the holes that they needed to do. But their thought process was, obviously they thought about that they had to seal it up, but they just used some tape and they used some adhesive trying to keep that tape on there. And obviously it didn't work really well. So that's one of the things that have to be provided on plans, is telling us, how are you going to make sure to seal up all of the penetrations, and how is that sealant going to make sure that it doesn't dislodge? Because as you saw, that tape dislodged, right? It came off, whether it was from some humidity or the heat or the wind, whatever the case may be, it did not stay there for very long. So penetrations really need to be paid attention to make sure that we ensure that the integrity of that thermal envelope is maintained for that air barrier. Now, when we talk about penetrations, we also have to keep in mind about concealed fire sprinklers. The requirement for concealed fire sprinklers is, it's not a one size fits all, obviously. You need to seal these however the sprinkler manufacturer states you need to seal them. Now, if you recall, typically we see concealed fire sprinklers in what? Residential construction, right? In those R2s, R3s, so that it's a concealed sprinkler that's part of that thermal envelope. We're going to also have to do air leakage testing. I can tell you, if you aren't sealing those areas up, you will probably not be able to pass the testing. But you also can't just place some caulking around the cover plate here. It then prohibits the sprinkler head from functioning the way that it was intended to function. So you just need to make sure you know how the fire sprinkler manufacturer wants those to be sealed. The last one is dealing with recessed lighting. And while this is a requirement, an incredibly important requirement, the nice thing is the lighting industry has really taken hold of that energy code. And I don't know, you guys have probably seen those little stickers that you find in there that says, hey, I'm IECC compliant or energy code compliant. And that means that it can be in contact with insulation. The housing has a very specific air leakage rate that it does not exceed. And then we've got gaskets that seal it up where it's penetrating through that drywall or whatever the material is. Now, the other component of this that we have to think about is, what are we going to use as an air barrier, right? We can't just use any material we see and say that's what we're going to have as an air barrier. The code states if you're going to use a material, that material cannot have air permeability that exceeds 0.004 CFM per square foot when it's under 75 pascals. Now, the nice thing is, instead of having to go and try to figure out what type of materials you can utilize, there are 16 items that are listed in the code that are already deemed to comply. And so we're going to walk through some of those, or well, we'll walk through all of them. But the first one is, plywood or OSB, as long as it's at least 3/8 of an inch, extruded polystyrene board, so that rigid insulation that we see a lot of times on the exterior could potentially also be your air barrier as long as we have joints and seam sealed, which guess what? Most installation manufacturers call out in their installation instructions in Chapter 3 of the IECC, along with all the other code books, all have a section that says, hey, you got to install materials, equipment, appliances the way the manufacturers recommend for them to be installed. So here's where you could have one material kind of taking care of two requirements. Not that I'm promoting one over the other. I just like to show options out there. Our foil face polyiso, as long as it's at least a 1/2 inch, can be your air barrier. Closed cell spray foam. Closed cell spray foam per the code says that it has to have a thickness of not less than 1.5 inches. But if you found a manufacturer that said, hey, I can do it at 1.25 inches, then you can go with the manufacturer's installation instructions. But typically closed cell spray foam as a whole, once you hit 1.5 inches, you're also a closed cell spray or also an air barrier. Now, open cell spray foam can be utilized as an air barrier, but whereas closed cell only required 1.5 inches, open cell, you have to get all the way up to 4.5 inches. And open cell does not have the R value that closed cell does. So you may not have the space in your wall to get the enough insulation in there too. So it's all about planning for sure. Now, exterior or interior gyp board or cement board, as long as it's at least a 1/2 inch thick, can be considered as a material. So that's why I said earlier that when the testing could be performed is that they probably will have the drywall up because it might be part of their air barrier strategy. And then we have our roofing materials. And yes, I do have 211s on here. And the reason why I'm showing 211s is because in the 15 and 18, it did allow for single ply roof membranes, but it had to be fully adhered. In the 21, they removed the requirement that it had to be fully adhered. So now single ply roof membranes are considered to be an air barrier when utilized. So these are the types of materials that may be utilized up on the roof to make sure that we're maintaining a continuous air barrier even at the roof level. Portland cement, sand purge, gypsum plaster, as long as it's 5/8 of an inch, cast in place and precast concrete. So those precast buildings, those are considered to also contain an air barrier. Fully grouted concrete block masonry, sheet, steel, or aluminum. Now, metal buildings, not metal studded buildings, but the actual metal buildings where we've got girders and purlins. A lot of times people are asking about how do they have an air barrier. This is how their air barriers are created, how they have that option. It's already deemed to comply. They overlap. They're pretty darn tight. So that's how metal buildings usually get their air or utilize an air barrier. The last one is CMU that's constructed of, clay or shale. So these are the 16 already deemed to comply materials that can be utilized as an air barrier. And then of course we have 3 assemblies. And the one I want to bring your attention to is the third one, right? We've got stucco or plaster as long as it's at least a 1/2 inch thick. So that may be locations where you find that. Now we also, I have a real quick question for you all. If I were to ask you about what do you typically find when you are a 2B building that's getting utilized as your air barrier, anybody have any thoughts or anything they would like to share on that question? So to be construction often utilizes for their sheathing Den's glass, right? Anybody disagree that Den's glass is not often or that type of material? And Den's glass, while it's not a continuous insulation, what it is it's at least a minimum of a 1/2 inch chip with fiberglass mats on both sides, right? And that's typically because it's a 2B construction and it deals with, moisture and all of that fun stuff. And that's what's installed on the exterior side for our sheathing for those 2B or non-combustible buildings. Keep in mind that Den's glass is also considered to be an air barrier because the core of it is gyp. 1/2 inch gyp is considered an already deemed to comply material, and the Den's glass is typically sealed. All the joints and seams are sealed. So you're kind of having one material that could potentially be dealing with 2 requirements. I just wanted to throw that out there so everybody understands that Den's glass can be considered as an already deemed to comply material and why it's deemed to comply. All right, so when we're talking about trying to control air, which is basically what we've been doing for the last little while, we have to understand that there are other parameters that we find in the code book that are really there to support the control of how air movement is going to happen. And the first one is dealing with our fenestrations, right? There is a requirement that your fenestration cannot have an air leakage rate that exceeds the values that you're going to find in the table, which is what you see on the left-hand side there. So those windows, typically, I would say the majority of them pretty much do kind of meet this anyway, but I want that information on the plans. I want it said that this is it. This, I think, could be in a spec book because the values haven't changed and window manufacturers are complying with this when they're doing their building of the glazing. The other one is rooms containing fuel-fired appliances. So if you have fuel-fired appliances and you are actually bringing outside combustion air and you have a high-low or high, however you're doing it, and you're dumping outside air into that building for combustion for that fuel-fired appliance, you are going to have to do one of 2 things. One, either have that space completely outside of the thermal envelope, or what you're going to do is thermally isolate that room from the rest of the building. So that means insulating walls, ceiling, floor to the values that you find in the table. You're going to have the doors will have to have a gasket and they can't be louvered. And then any lines or ductworks that are going in and out of that room will also have to be insulated. I know a lot of people say, well, why is this even in here? But if you think about it, remember that R2s, R3s, and R4s that are 4 stories or more follow the commercial provisions. So some of them do still have the little furnace in there, and it is dumping outside combustion air into that room. So hopefully that design isn't getting utilized a whole lot, but it does happen, and we want to make sure that we are not allowing that unconditioned air to mix with our conditioned air. So doors and access openings that are going to go into shafts, chutes, stairways, elevator lobbies, all of them are going to have some sort of gasking or weather stripping to it, because we're trying to make sure that the conditioned space is not getting infiltrated with that unconditioned space. We've done a whole really good job with the thermal envelope, and then we have the laundry chute, and that laundry chute obviously is not conditioned, but yet we have an opening to it. So they're just saying, hey, by the way, gasket it, weather strip it, something along those lines. But understanding that the energy code realizes that there are very specific requirements when it comes to like fire rated assemblies. And so you're going to look into 716 of the IBC. And if 716 of the IB says, hey, it's got to be this way, then obviously it needs to be this way, and this may not come to full fruition. All right, intakes and exhausts, right? We have been talking about, how do we make this really airtight, making sure we have a really strong, robust thermal envelope. We got testing going on, we got commissioning going on. Then we have these big openings for air intakes and exhaust, which we want. And we just need to make sure that they have dampers on them. Now, the dampers, according to C403.7.7 of the Energy Code, does state that they have to be motorized unless you fall under one of the exceptions. So there's a good chance that the dampers that will be required for your intake and your exhaust will also have to be motorized. Loading docks, we need to make sure that the loading docks, as you can see here, have the sides and the top where there is material there that it's going to restrict the amount of air infiltration that happens when a vehicle is, backed up and getting unloaded or loaded, whatever the case may be, because there's going to be that interaction of the outdoors being brought in type of deal that we're trying to limit how much air can actually come in through these. Vestibules. Vestibules are required at building entrances. Notice I said building entrances and not building exits. The vestibules are required for them to have self-closing doors. And in theory, the idea is that the first door is not going to be open at the same time that that second door is, right? But we all know we walk through that first door, somebody's walking out that second door, and they both may be open. But the idea is if I am the only one trying to go through this vestibule, I walk in the first door, the doors open up, I walk through, they close, and then the second doors open up and close in that particular way. It does talk about revolving doors. Do not eliminate the requirement for the vestibule when you have doors that are adjacent to those revolving doors. So if you have a revolving door here and then what's adjacent to it, the adjacent door would be required to have that vestibule on it. Now, of course, there are exceptions, and you can see those on there. Probably one of the big ones would be, okay, it does say if you're going into a mechanical, electrical room, something of that intent, or if it's just for employees to go in, it doesn't require a vestibule. If it's a door going into a sleeping unit or a dwelling unit, you don't need a vestibule. If it's not opening up to a space that has 3,000 square feet in area, it's not required. Revolving doors. Doors that are utilized for vehicular movement. We saw that a couple of slides ago. That doesn't require to have a vestibule. But number 7, I want to talk about number 7 really quickly here. So number 7 says, hey, you don't have to have a vestibule. You can have an air curtain. And the idea of where the air curtain was brought into code was in the 2015 edition of the IECC. The 2012 had no chapter 5 that dealt with existing buildings. It basically said existing buildings have to comply with the code as if they were new, except for a couple of exceptions, which meant existing buildings would be required if they had any sort of alteration, anything that they did to the place, they would be required to put in a vestibule. Well, not all spaces can accommodate that. When you start looking at, some of, let's go downtown and we look, there are buildings that would not be able to accommodate having those vestibules in there. So the idea was, okay, so what can we do to help those existing buildings? And so air curtains were brought in under the 2015 to help for those existing buildings. Well, at the same time, Chapter 5 was developed and voted on to address, how do you deal with existing buildings? But this one never was removed from here and brought over into the existing building. It still resides here. But that's why air curtains were brought in. It was not an air curtain instead of a vestibule because a brand new building wanted to do air curtains. It was really there as an option for those existing buildings to be able to comply with the energy code. All right, this is brand new. So we've done a whole lot of work on making sure we got a tight building, we got an excellent insulation system, we got an excellent air barrier system. And then we have these very large garage doors or a wall of windows because we're a yoga studio, or the garage door because we're a restaurant or a bar, because we want to bring the outside inside or the inside outside. I'm not really sure which direction they're trying to go on that. And it's been very popular. The problem is then you have mechanical equipment that is working incredibly hard and trying to get the temperatures to what they had been set at. And so what this does is says, hey, if you have an opening that's larger than 40 square feet, what you're going to do is all of a sudden, if that window, opening, door, whatever it is, has been open for more than 10 minutes, now what you're going to do is you're going to change the set point for your heating and cooling. You will change your cooling set point and move it to 90 degrees. And if you happen to have it open because it's cold outside, I don't know, then you can only heat that structure to 55 degrees. Now, there are some exceptions, one being that first entrance door when you're walking through in a vestibule system, because sometimes those doors, people are coming in and out, and it might be, 10 minutes, it registers it. So that is exempt. The other one is because this is something that's pretty applicable and utilized in bars and restaurants, the areas that are zoned separately, and those zones are associated with the heating and cooling for where food is being prepped, those can be exempt from the set points. We don't want to kill off the cook, right? So the last one is dealing with warehouses and those overhead doors, because a lot of times they have those doors open as such because it's part of their ventilation strategy, because you are permitted to do natural ventilation instead of the mechanical ventilation, which has been a very common occurrence for how warehouses function. Now, that one is only applicable if the code official says, yes, we're going to go ahead and exempt the warehouses. Now, something I really want to have all of our architects and designers keep in mind. I want to help me so that everybody loves to get your plans. And the idea is, there's always a question, what do I put on my plans? What do I place in the spec book? On your plans, because the testing requirements, as you can see, really got beefed up, and there's going to be a lot of situations, in my opinion, of what's about to come with all of the testing. You need to make sure that what you have on the plans is, you tell me specifically what are you utilizing as your air barrier material or whatever the assembly is. Call that out on your plans. A lot of times I see air/moisture barrier, which in my opinion does not specify it enough. You got to make sure that the contractor out in the field knows exactly what they have to pay attention to as far as joints and seams, right? And which leads us to the next one. How are we sealing up all those joints and seams? How are we sealing up the penetrations? All of that is incredibly important. And it might not be a bad idea. You should really place all that information in your wall assembly sheet. You put your fire resistant rated construction, your listed assemblies, all of that. So just start including that with that information, even if it's just a note. The DensGlass is our air barrier. Seal all the joints and seams with mastic. Seal all the penetrations with XYZ sealant. Whatever the case may be, just call it out on your wall sheet. Call it out on your code analysis. And make sure that we have it straight so that we can set up all of our projects to be successful. Now, things that can be in a spec book is, I think, air leakage for fenestration can be in the spec book, or the information about the loading dock, weather sealing, right? All of that could be placed in the spec book, and I think that would be perfectly okay. So this is me. I hope I gave you guys something to think about when thinking about air barriers. And if you have questions, I'm happy to answer any.
Great, thanks so much, Hope. Looks like we've got one question in the chat or in the Q&A, and it's how long dense glass can be exposed to weather conditions and still be an air barrier?
That's an excellent question. That would probably be something that is probably listed on the manufacturer's specs. I've seen dense glass exposed for, months on end for commercial projects, right? Because they're large, but that dense glass, the fiberglass mat is often a part of the water resistive barrier system, because it can be the water barrier or water resistant barrier for a project. So as long as the joints and seams are sealed, it can be exposed. Unless the manufacturer's specifications say something to the contrary.
Right, makes sense. All right. Let's see. I think that's all the questions that we have.
All right. Well,
But
thanks everyone for listening to me jabber about air barriers.
and thank you, Hope, for the presentation today. I'm going to go ahead and end that recording.